Hello, and in this lesson we'll be looking at different ways that we can interpret, describe, and begin to talk about data and different data sets. The first way that we can look at data is by describing the type of skew or the type of shape that our data may take up. The most common, or I guess most regular kind of curve that we would see when we're looking at data sets is a normal kind of curve. And the other word for a normal curve that we might see is symmetrical. And essentially what we're looking at with a normal or symmetrical curve is that we find most of our data falling in the middle section of our curve, meaning that scores that are in the center of our data set have the highest frequency. Our next type of data is negative skew, and that's where scores of higher value have higher frequencies, and it takes a shape similar to the one shown in the picture. Positive skew is the opposite of this, where scores that are lower in the data set have a much higher frequency and have a shape similar to this. You may also see examples of bimodal skew, where we might have two areas of high frequency, one in a lower section of our data set and one in the higher section of our data set. Another way that we can begin to describe our data sets is by talking about outliers and clusters that may appear in our set of data. Outliers are pretty much values that don't sit amongst most of the other values that we may find in our data set. They're sort of outsiders and don't really seem to follow the same pattern that the rest of our data does. In our dot plot, what we can see is that these two values here would be considered outliers, as they are not a major part of the rest of the data set and they're quite spread. What we can also see is that we have a clustering of data, and this is the data that seems to be more regular. They are groupings where many values exist, and they are all grouped up in a small range of our data set. We can use this and our ideas of skew that we learnt about before to begin to talk about data presented in questions like this. So for example, we're given a set of data about two classes, and we're asked to essentially compare both of the data sets and compare which class may perform better, assuming that this would be test results. So the first question asks us to compare the shapes of both data sets. What we can see is that class 1 has a negative skew because all of the data is clustered in the higher scores of our data set, whereas class 2 has a positive skew where the lower values are clustered and are more frequent in the lower end of the data set. That begins to answer question B, which asks if there's any clusters or outliers. We can obviously see two clusters that I've circled there already. We wouldn't consider these kind of values like 9 or 61 to be outliers, as they're not spread out far enough from the rest of the data, unlike the ones over here which have a clearly quite sizable gap between it and the major cluster. The final question C is which class performed better, and we're asked to justify our answer. And what these questions are essentially getting us to do is make the judgment or assumption that if a set of data has a positive skew, we can begin to assume that that set of data would have a greater mean, which would generally suggest that the class with the greater mean would have achieved a better score. So as we can see, this set of data has a negative skew, which means that they have a higher overall score, which means that we can assume that they have a greater mean. We could prove that by calculating the mean for both and confirming that class 1 has a greater mean, which would therefore mean that they perform better in the test when compared to class 2.